Today we're going to come into GeoGebra and we're going to first create a quadrilateral of any kind. And we are going to label its vertices A, B, C, and D. So you can make a rectangle, you could make a square, you could make an irregular quadrilateral. It does not matter. So we'll make something a little different. And then we are going to construct the midpoints of each side by selecting two vertices, and it will find the midpoint between the two of them. We're going to create midpoint for each side. And so we can show the measurements of those. And so I would say, if I were making a guess about something within this, now we're investigating and exploring, my first conjecture would be that E, F, G, and H will always be the midpoints of their respective sides. So E will always be the midpoint, or you could say halfway between A and B. So these measurements should always be the same. These measurements should always be the same. These two and then these two all should stay equal. And so I can drag A and I can test that conjecture, and I can see that I can pull it all the way out to here. And AE is 7.4 and BE is 7.4, AH 5.49, DH 5.49. So I can test that with all the sides and see that E, F, G, and H are always going to be midpoints of respective sides A, B, and BC, CD, and AD of my quadrilateral. So they will always be the midpoints of those sides no matter what I do to A, B, C, and D. And I can't actually move them. So I will never have to worry about them changing from being midpoints. And so let's hide all of that. Now, let's connect points EF, FG, G to H, H to E. And again, I'm just going to do some measurements here so I can observe and form conjecture. And so it looks like EF and GH are always going to be congruent because they are right now. So I'm just going to say that they're always going to be congruent no matter what happens to my quadrilateral. And so I can test that by dragging points A, B, C, and D to see if that always is going to be true. So that's my next conjecture. And so let's see. They still are congruent. They still are congruent. What happens if I move point C? Oh, they're changing measurements now, but still congruent. Still congruent. So no matter what I do to points A, B, C, and D, E, F, and G, H are always congruent. And as I've noticed, E, H, and F, G are always congruent as well by default by moving these points around and noticing that as well. And so for my last conjecture, pulling this information together, I'm going to say that EFGH forms a parallelogram. So if I want to test that, I can construct parallel lines using this tool. So if I want to construct a parallel line going through F that is going to be parallel to EH, I would select F because I want it to go through that point and parallel to this line. And let's do the same thing. So I want a parallel line going through E that is going to be parallel to this segment here, FG. And so now I can move these around. And these parallel lines, so this line here is always parallel to this side of our quadrilateral through point E. And so these two lines are always staying parallel because we have constructed them that way, but they're also passing through both points on opposite sides of our quadrilateral. So we see that we have one pair of parallel sides, and a parallelogram requires two pairs of parallel sides. So let's hide those. We don't need to see those because we're going to test the other pair of sides that we have here and see if they're parallel. So we're going to want a parallel line, same thing like we did, through H, parallel to this side. Then we're going to want a parallel line through E, parallel to GH. And again, these sides, no matter how I move A, B, C, and D, are always parallel, but they always pass through the 2 points that make up the segments for the 2 opposite sides of our quadrilateral, And so our second pair of sides is also parallel. So we have a quadrilateral with 2 pairs of parallel sides, which makes it a parallelogram. No matter how we move these, we are always going to have parallel lines here, and we can put these back. And so we can see all 4 of our lines, which are passing through all 4 of our vertices for our quadrilaterals all the time. These 2 lines are parallel, these 2 lines are parallel, so we have a parallelogram. So I was able to prove and provide evidence and justification for my third conjecture that EF and GH is a parallelogram because I was able to construct those 2 pairs of parallel sides for the quadrilateral that was formed by the midpoints of quadrilateral A, B, and C, and D, which was EFGH is the midpoint quadrilateral. And that is all I have. Thank you very much.